A white dwarf, just one astronomical unit away, would be invisible to the naked eye, yet it would still contain the mass of an entire sun crushed into a sphere the size of Earth. A teaspoon of its material would weigh about 5 tons. But what's even crazier is that this is one of the gentlest ways a star can die. Stars do not simply switch off. They collapse, explode, or dissolve. And the method depends entirely on how much mass they started with. The smallest stars in the universe, red dwarfs, are so efficient at burning fuel that some may still be alight over 100 billion years from now, long after our own sun is gone. No violent collapse, no explosion, just a slow fade into darkness across a timescale longer than the current age of the universe. But most stars do not get that quiet ending. Take a star like our sun, run it through 10 billion years of fusion, and once the hydrogen runs out, you get a red giant. The outer layers swell outward, potentially engulfing the inner planets of its system entirely. Mercury and Venus would be consumed, and Earth's surface would be scorched beyond recognition. This has nothing to do with any documented event. It is simply the calculated fate written into the physics of every sun-like star. And when a red giant finally lets go of its outer layers, it does not go quietly. It sheds them into space in glowing shells of gas called a planetary nebula, leaving behind that white dwarf core we started with. These structures can span over a light year across, glowing for tens of thousands of years before fading into the dark. So the smallest, calmest death conceals something enormous still expanding around it. But this is still one of the tamer entries on this list. Here is the unsettling part. Once you cross a certain mass threshold, roughly 8 times the mass of our sun, the star's death stops being slow and starts being catastrophic. A massive star can burn through its fuel in a fraction of the time a sun-like star takes, and when its core runs out of options, gravity wins instantly. The core collapses in less than a second. The rest of the star does not know yet. Light takes time to signal outward, so for a brief moment, the star looks completely normal, while its interior has already ceased to exist in its original form. That collapse triggers a supernova, one of the most energetic events physics allows. For a few weeks, a single dying star can outshine its entire host galaxy of hundreds of billions of stars combined. The shockwave forges heavy elements in seconds: iron, gold, and uranium, then blasts them across hundreds of light years of space. Every heavy atom in your body, in the ground beneath your feet, in your own bones, was likely forged in an explosion just like this one, billions of years before Earth existed. But not every supernova ends the same way, and this is where things become strange. Sometimes the remaining core keeps collapsing, packing more mass than our entire sun into a sphere just 20 kilometers across. This is a neutron star, and it is so dense that a single sugar cube-sized piece of it would weigh roughly 1 billion tons on Earth. Some neutron stars spin over 700 times per second, sweeping beams of radiation across space like a cosmic lighthouse. We call these pulsars, first identified in 1967. But somehow, even a neutron star is not the strangest thing gravity can build. The next one on this list doesn't just crush matter. It erases it. Push past roughly 20 solar masses at collapse, and neutron pressure itself fails to hold the core together. Nothing known in physics can stop the collapse after that point. The result is a black hole, a region where gravity is so extreme that not even light can escape it. The boundary marking the point of no return is called the event horizon, and once anything crosses it, from our perspective, it simply disappears from the observable universe forever. So what happens if you get close to one without crossing that line? Gravity near a black hole is not uniform. It pulls harder on whatever is nearer to the center, stretching an object along its length while compressing it from the sides. Astrophysicists call this spaghettification, and near a small enough black hole, it could happen to a falling object before it ever reaches the horizon. No warning, no resistance, just an inevitable stretching pull that grows stronger every second. But the next black hole is terrifying for the opposite reason. At the center of our own galaxy sits Sagittarius A black hole with a mass around 4 million times that of our Sun. Despite that staggering mass, its event horizon would fit comfortably within the orbit of Mercury, making it, relative to its size, smaller across the sky than a tennis ball would appear sitting on the surface of the Moon. It was finally imaged directly in 2022, confirming decades of indirect evidence about the invisible giant anchoring our entire galaxy in its orbit, like a lion sleeping at the center of everything we call home. If you have followed this list all the way from a quiet dwarf star to the center of our galaxy, consider dropping a like right now, because the next entries are where stellar death stops following the rules entirely. Sagittarius A is massive, but it is dwarfed by something else. Some supermassive black holes exceed 10 billion solar masses, anchoring galaxies far larger than our own. One of the most extreme known examples, TON 618, has an estimated mass equivalent to swallowing an object the size of Pluto's entire orbit without difficulty. And here's the strange part. Objects like this do not always announce themselves. Many drift through space without any bright accretion disk to give them away, invisible until something wanders too close. That leads to something even harder to detect. A rogue black hole is one that has been ejected from its original system, flung out through gravitational interactions, and left to travel alone through the galaxy. We have never directly confirmed one drifting freely nearby, but the mathematics says they must exist in significant numbers. Nothing marks their location. Nothing warns you they are there. A completely dark, completely silent object could, in theory, be closer to our solar system than we currently know, and we would have no way of confirming it until its gravity began to interact with something we can actually observe. And that brings us to the strangest theoretical death of all, one that never even requires an explosion. Under certain conditions, a massive star can collapse so completely and so symmetrically that it forms a singularity without any protective event horizon around it at all. This is called a naked singularity, a point of theoretically infinite density exposed directly to the rest of the universe, where the known laws of physics may simply stop applying. Some physicists argue something in the structure of reality forbids this from ever forming. A hidden rule the equations seem to require in order for the universe to keep functioning normally. Nobody has ever observed one. Nobody knows for certain if one could exist. And if it does, it would represent the single strangest way a star's death could break the universe's own rules. From a white dwarf quietly fading over 100 billion years to a singularity that might expose the raw edge of physics itself, every stellar death sits somewhere on this scale between quiet and catastrophic. And the deeper you look into it, the more the universe seems to be holding back, far more than it shows. If you want to keep exploring what's hiding in the dark spaces between the stars, subscribe and stay close, because the next journey into the universe's secrets starts right after this one.